Good morning and good evening, everyone. So I just started server and installing Docker, and let me log in to install Docker Compose. So I can make that as part of our Docker install script also. Yeah, when you're practicing, just add these two commands to your Docker script. So yesterday we got an error by doing the payment configuration, right? So I just corrected the code. So you no need to worry because that's part of developer job, application developer job. So I just removed few things that comes from Instant. Actually, we don't require that. Okay, I removed the components. Now everything will. What is the flow we are doing now is we are writing our Docker file, building image, and then we are running Docker Compose. Okay, so this is the way we are installing RoboShop as Docker containers. Let us do that now. RoboShop Docker, copy the code, git clone, cd RoboShop Docker. So first I need to build the images. I don't have any images right now since it is a new instance. I need to build the images. Yesterday, just wrote something. Yeah, this one. Let us build the images. So this will build all the images one by one. So I can push these images to the Docker Hub so that you guys as a DevOps engineers or whatever, you can use those images to run the RoboShop application within few minutes in your servers. Okay, so we'll do that also. Someone of you, please be ready. Your Docker and Docker Compose both installed. Once I push the images, you can just get the Docker Compose file from here and you directly run the Docker Compose, you will get all the applications so that I can say Docker is completely portable. Wait few seconds to build all images, few minutes. Is getting built. Shipping is good now. Okay, so all images are built. Okay, we have all the images available. So now I need to run Docker compose up -d. Okay, so everything is done. Now if I open this, I should get the application here. So let me test. User is done. Cart is done. Catalog is done. Checkout. Shipping. First time it will take some time to load. Let us see. Happen to shipping. Shipping is done. And shipping is running as well. Where is it? Web payment shipping is running this. Yeah, got it. Yeah, so that's it. Payment is done. So now I say Docker is portable. What is portable actually? Portable chair versus non-portable. So this is portable chair. You can just fold it and then you carry it. So this is obviously non-portable chair. So this is non-portable chair. What is the disadvantages of this chair? So you cannot fold it. It will occupy the space. So mostly it is space. You cannot carry easily in your car or bike. But this one is completely portable. Or this one is completely portable. You can see. So you can fold it. You can save the space and then size so that you can easily carry. So the same process I did, whatever I'm doing in Docker, the same process I did in Ansible. What we did in Ansible, we took one AMI and we configured server like here CentOS 8. We configured server like we installed Node.js and then what else we installed, for example, cart created, users copied, application, and then run application. So this also we can create as AMI, but what is this? Heavy size and occupies more space compared to Docker image. So that is why we can say VMs are not portable because they occupy more space and size, right? So Docker is portable because of its less size. Now, so I have GitHub. We have GitHub. What I'm doing, I'm writing here and then I'm pushing it to the GitHub so that you are pulling it and then you are working on. So I have the images right now. So if I push these images to this Docker Hub, I can pull anywhere. Like I can pull in dev environment, I can pull in QA environment, I can pull in uh, production environment. I can pull wherever I require. I can run that, right? So now I'll push these images. So instead of Docker build, what I'm doing here is, before that I need to log in. Docker login, join DevOps. Okay, login succeeded. Now I'm pushing these images. Docker push join DevOps slash $I colon V1. Okay, join DevOps is mandatory because I'm pushing it to the Docker Hub. Push, very close to the push. Oh, rabbit MQ test. Okay, so leave that. So I'm just tagging this join DevOps web, join DevOps slash web colon V1, web colon V1. And then user. So I'm just tagging all the join DevOps. So short slash. Okay, and then Docker tag user colon V1, or else you can just run for fast. What I can do is, yeah. So here, while building itself, I can do join DevOps slash and then Docker push join DevOps slash $I colon V1. Okay. So now I'm pushing all the images. So now what you guys should do, so take this Docker compose and then image, you have to use join DevOps and then shipping like that. Okay. So now I will modify our Docker compose. Now what I do here is, so this is join DevOps slash MongoDB, and then this is join DevOps slash catalog. That is, we are getting it from internet, and join DevOps slash user and join DevOps cart and join DevOps MySQL and join DevOps shipping. RabbitMQ is from internet, join DevOps slash payment and join DevOps slash web. So everything is I'm referring from the central Docker hub. Okay. So everything is pushed. Now let me push. So now any one of you, okay, just pull this Docker Compose, just copy this Docker Compose raw, and then run your Docker and Docker server. So let us take 2 to 3 minutes, and any one of you or everyone, just pull this and run your Docker server. Please respond in the chat. Is someone doing this? Okay, Rahul is doing. Anyone else? So we have the images available. So when you are running this, yeah, it will create networking also automatically. You just run this Docker Compose. That's it, nothing much. Okay, we have the image available. It doesn't, we don't care whoever built this, and we should have that image available. Then we can run this. It will automatically create our application. Once you are done, you can share your public IP address. Meantime, I can just create another server or else I can do it, but that will take some time. So you may have your servers running. Rahul, is it running? So now, meantime, I can also do it. Docker compose down. Okay. So now Docker, I'm removing all the images. Docker images -a -q. Okay. Now you can see I don't have any images available locally. So my Docker compose, so it is getting git pull. I need to run git pull. My Docker compose, it is getting the image from internet. First, it will check locally is available. If it is not available, it will pull from internet. Docker compose up -q. You can see pulling from join DevOps slash shipping. So it took less than a minute to configure the entire application running. So we can say Docker is highly portable, easily portable. So that is one of the advantage you should explain. Then if someone asks about Docker advantages, okay. So I'm sure you will also get this application running in your servers if you run this Docker Compose directly. So it is easily portable. So then our next topic we can discuss is on volumes. Okay. So one thing is Docker is ephemeral or image or container in Docker is ephemeral. Ephemeral means data will be deleted. Data will be deleted once you remove container. Okay? So that is called ephemeral. Now, for example, Docker run -it nginx and -p 80:80. For example, I'm running this nginx on port number 80. So first, let me run it in the background and then exec it -it and bash. Okay, I'm inside this. So now if you open 8080, I should get the Docker. So I got the Nginx welcome page. Now here I am going USR share Nginx HTML echo hello Docker hello.html. Okay. So now if I say slash hello.html, so I'm getting it. Now let me remove this. Exit Docker remove -f. Now I remove the container. So you will not get any response here. Port number 8080 will be just revolving. Now if I run the same command again, on port number 8080, welcome page is there, but let us see whether the hello.html exists or not. It's not there because the data you created inside the container or image is ephemeral. Okay, so data will be deleted once you remove the container, but our application, so it should not be ephemeral because we have a lot of user data and then we have a lot of cart and user is placing orders. We are storing this in databases. If you run containers, if you run databases as containers, okay, the problem is if we run DB as container, DB can be anything. So that can be RDBMS or MongoDB, that is called generally NoSQL, or Redis or MQ. So these are the data we require. This is very crucial. If you run DB as container, by default, data will be removed once your once container is deleted. Okay, so generally when we delete the containers, whenever we do new releases, we will remove the old container and then we will spin up the new container. So that's the usual release process. And then similarly, sometimes you may face problems with the containers. You will restart them or you will remove and then recreate them. So at that time also the data will be removed. So for that, Docker is giving us one solution that is called Docker volumes. Okay, so there are two types of volumes, that is unnamed volumes and then named volumes. So what is unnamed volumes? Let us see. So -p is host port and then colon container port, right? So similarly, we have -v colon host path and container path. So let us see that what it is. So Nginx, where it is referring HTML, can someone please type in the chat? Nginx generally, where is it referring for HTML? Please write in the chat. That is USR share Nginx /HTML. So this is where Nginx look for HTML pages. So in this container, you cannot change this. This is already fixed by the container, just like the port is fixed by the container. So the path is also fixed by the container. Now what I can do here is I can create some directory like Nginx -data in my system, and then I can map this with container directory, so that even when you delete this, this will be persistent. Okay, so that is the characteristics of volumes. So now what I do here, I'm creating one directory in my home folder, Nginx data. For example, let me go there. So I created Nginx data. So now what I do, Docker run -d -p. I need to give this. So /home/CentOS/Nginx-data. I am mapping the directory in my host with directory inside contain. Okay. So before that, I'll just show you where the Docker stores. Docker ps. Where is our Nginx? This one. Docker remote -f. Docker inspect. So you can see here, when you inspect, you can see where it is storing the data by default. See, the data is stored inside these things where lib docker overlay 2 and somewhere here. For example, let's go here. Maybe you need sudo for this. Sudo su hyphen work. Okay, generally, whatever your Nginx store, it will be here. So we don't know exactly in which location it is storing. Maybe somewhere inside this. Okay. Find dot -i index.html. For example, let us search. You can see it is inside merged folder, cd merged. You have the entire OS kind of structure. It's there where it is showing USR share Nginx HTML. So here it is available. So here your Nginx is storing the HTML data. Okay. So now if I remove, let us see. The directory exists or not. Just going sudo su hyphen. Yeah, by default, the directory is also deleted. So Nginx is creating temporary volumes inside, sorry, and Docker is creating temporary volumes inside var lib docker overlay to directory. Okay, here temporary volumes. So when you remove the container, the temporary volume also will be deleted. So for that purpose, what I'm doing here, I created one directory. I'm not allowing Docker to create temporary volumes. Okay, I created one directory and then I'm mapping here with -v /home /CentOS /nginx-data. I'm mapping this with USR share nginx/html. Okay. So now nginx-data. So I'm inside the host. Okay. Now let us just :8080. So you are getting welcome page. Now let me log in inside the container. Docker exec-it and then bash cd usr share nginx html echo hello docker hello.html. Okay. So now let us just type hello.html. Okay, I'm getting hello docker. Now exit. Let me check here. You can see hello.html came here. I logged in into the Docker and then I created the file here. So since I am mapping this location with this one, whatever the HTML stored here, so automatically they are mapped with this location. Now you can give hello volumes /volume.html or HTML. Now you can just give volume.html. So you are getting this. Why? Because I am mapping the directory, local host directory inside the container. Okay, so that is why. Now let me remove the container. Docker rm-f. Still my data is exist here. Okay, so now you can map this data with another container. So you can map this data with another container, same container. Your data is persisted, it is not deleted. You can just see, right? So this is the volumes, Docker volumes. So you create a directory inside your host and then you map the directory with the container path, then your data will be persisted. Data will not be deleted even you delete the container. So these are called unnamed volumes. So what are unnamed volumes? Here you create directory. Since we are creating the directory, we have to manage. We have to manage the directory. So now let us see named volumes. Functionality is same, but let us see that. But we will let Docker to manage the data. So Docker volume ls. So these are the volumes available generally. Docker volume help. So now you can create the volume. Docker volume create, for example, Nginx. I'm creating Nginx. Now you can see Docker volumes, Docker volume ls. So these are all the temporary volumes you can see. But this is the named volume. I created a named volume, but where is it again? Docker inspect Nginx. Or inspect volume Nginx. Okay. Docker volume help. Docker volume inspect and then Nginx. Docker volume inspect Nginx. So where is it? Var lib Docker volume. So now there is a directory created named volumes. So there is a directory created inside var lib Docker volumes and then Nginx, the name you have given, and inside that there is a underscore data. So this is named volume. This is not the randomly generated ID. This volume is going to be created by the volume will have name. Everything can be managed by Docker commands. Okay, so you can list the volumes, you can create the volumes, you can ls, you can remove, you can prune, you can remove, you can do everything. But if you create the directory like Nginx data, I have to delete it manually through manual commands like rm-rf, or I need to, I don't have any names actually. But here the difference between named and unnamed volume is nothing but named volumes are managed with Docker commands. The volume lifecycle also can be managed by Docker commands, but unnamed volumes, we have to take care of it manually. Okay. So now I created the volume. Now I can do. So let me remove the RoboShop containers actually. Docker compose down. Okay. Docker please. I'm removing this. So now instead of this directory, so instead of this unnamed volume, I can directly give my name of the volume. So what is it? I created this Nginx. Okay, so now you can see whatever the every data will be persisted. Docker exec -it bash cd share Nginx HTML echo hello named volumes. So whatever the data it is created, we can see that inside this directory. To go SU. Okay, you can see your hi.html. Now let me remove that container. Docker rm hyphen here. Still the data is existed. The folder is not deleted. Okay, so that you can mount again. You can mount again, and then you can see hi.html. Okay. So generally, that's what we do. We create the volumes. If you are working with Docker and you want the persistent storage, okay, your data should not be deleted. Then you create the volume and then you mount the volumes to your containers. Okay, so that's what we do. So now, what are the stateful applications for us? Like the stateful applications are MongoDB and then MySQL and Redis and RabbitMQ. So these are stateful applications. Database kind of applications comes in database tier. So now for this, I have to create the volumes. So generally, you can create Docker volume create, but here, just like networks, you can just have volumes and then you can mention the volumes. Docker compose volume. Okay. So generally, you can just mention your volume name, so it will be automatically created. So yeah, like this, you can just mention the volume name, it will be automatically created. You can have some options also, but it's fine. We are using default options. You can give some labels to your volumes. You can give name, but automatically this can be the name. So now I will mention volumes, and the volumes I need is MongoDB. That's it. The name also can be as MongoDB, Redis, and then MySQL and RabbitMQ. So these are the volumes I require. So when Docker Compose is working, Docker Compose in background, it will run Docker volume create MongoDB, Docker volume create Redis, Docker volume create MySQL, Docker volume create RabbitMQ. And then I need to mount them here. So like -v option I mounted here, right? Similarly, inside this also I need to mount for MongoDB. There will be a section called volumes, and here you need to give your source. So let us see that actually we can give here. Yeah, I can see here volumes. You can mention like this, but these are stuff you can mention like your volume name, like MongoDB slash where you want to mount it. Otherwise, you can mention as source and target. Okay, source is MongoDB, and then target. So where MongoDB stores the volume, we don't know. So we need to check the image. Let us check the image. It's persistent. You can see it is storing the volume inside data/db. So just give that data/db. Okay. And then just we will mention it as volume. Yeah, that's it. So this is the source and this is where the target and just mentioning it as volume. Generally, this is also not required. Let us just check. So they are saying type is required, missing property type. Okay, let me mention the type also. Type is volume. Okay, that's it. So the same Redis. Source is Redis, but we want to know where Redis is storing the data inside containers. So you have to check the Redis image. So Redis is storing just data/data. So that's it. So the target is /data. And now MySQL. Source is MySQL. And the target is, I know generally this one, where lib MySQL. Okay. And one more thing is RabbitMQ. Source is RabbitMQ. And then let us check for the target. -p. Data. Just search with data. So this is the data actually. Where lib RabbitMQ. Where lib RabbitMQ. Okay, so this is where all the data will be persisted and we mapped it. Now let me just push and pull Docker compose up -d. And you can see the volumes are created automatically. Now our application is running. So now let me add something. Slowly. Still loading. See that. Yeah, now it is done. Okay, so order is placed. Now what I do, I will remove everything. Docker, compose, down. But I expect my data should not be deleted, even if I create the containers again. So it should go unattached to the existing data. Okay, so now nothing is running here. Now I will make the Docker compose up and running again. Okay. So now let me check. Now you can see still my order ID exists. The user exists, the order ID exists, everything is existed just because of Docker volumes. You can remove the containers, but your data will be stored. So this is everything about Docker volumes. We have this topic again in Kubernetes. That is very much important in Kubernetes. Okay. So now I can say we configured successfully using networking volumes. We built the images, RoboShop images. This is the same way you follow in your any application if you face any project. So the same way you create Docker files, the same way you build the images, you push the images, and you create the Docker compose, and you run your application as Docker containers. So now let us discuss some best practices. Just learning the concept will not help you, but definitely the interview is a standard interview. They may ask a proper interviewer, definitely they will ask what are the best practices you can implement inside Docker. So doing these things, anybody can do. Anybody can learn Docker, anybody can learn Docker volumes, Docker networking, anybody can configure the project as Docker. Not anybody, at least someone who learned very well. But the peaks level of learning is knowing the best practices and implementing the best practices. Okay, so now let us just take the help of ChatGPT. Already creating your own network is one of the best practice, and then creating volumes is also one of the best practice. Now let us ask ChatGPT what are the best practices while working with Docker. So it is giving use official images. So we are already using official images. One of that we already implemented. Create custom Docker files. We are doing that, and keep containers small. It means reduce the images and then smaller images. That's what they are saying. So now let us implement something here. Let me take user or cart. So this is 949 MB. So almost 1 GB. So I want to reduce it to the less memory so that it can be easily portable. If you see that RabbitMQ is 217 MB, Redis is 138 MB, very less in size, but our cart is taking almost 1 GB. So we want to reduce the size. How can you reduce the size? Mm, So node 14. So it is pulling node 14. So let us just Docker pull node 14. Docker images. And see node 14 itself is 9112 MB. So that is why it is taking too much too much memory. So now I want to use less version, less memory. So we have Alpine is always the Alpine is the very less in size image. Okay. So let me take that Alpine. So go to Docker Hub and go to Node. So there will be Alpine version also here from the official image itself. And we need 14 Alpine. So just let us search for 14 Alpine. The 16 Alpine. 20. Yeah. So we have many Alpine images in 14. So let me take the latest one. So I will use, instead of this, I will use Node colon 14, but it is Alpine version. So now I'm pushing and then I'm pulling etcd cart, okay, cat docker file. Now I'm building this because I changed it. Cart colon v1 join DevOps slash cart colon v1 and then dot. Now let us check the memory. Docker images join DevOps cart colon v1. You can see how much it is. 152 MB. So just reducing the size, image size is not enough. It should work. So now let us run Docker compose up hyphen t. It is recreating cart because it is changed. So it should work. Okay. Cart is recreated. Now let us check our application. So cart is working. I reduced the size to, you can see, from 950 to 150. And I used official images. So you can apply this Alpine official to all other images like payment. You can see 1.03 GB and then shipping. So you can use it everywhere, wherever you have the more MB. But your aim should not be only to reduce the image. You should test completely because the less Alpine images, they don't have anything at all. It's bare minimum, very, very bare minimum voice. So you should thoroughly test it. If you satisfied with the testing and the results, you make sure your application is working, then we can go with it. Just simply to reduce the image size or container size, don't go with Alpine. Do proper testing. So now what is our payment? Payment is working Python, right? So you can try, but it's not guarantee. Okay, sometimes it will work, sometimes it may not work. You have to take extra care. So you need to spend some time and efforts to make that work. So let me take Python. And that's 3.9. Let us check for Alpine version. 3.9 Alpine version we have available. So let me use this. Let us check. Docker build -t. Let me keep it as join DevOps slash payment v1 dot. So something is not working in Alpine. Yeah, so actually we need to spend some time and then understand why it is not working. As I said, just to reduce the memory, you should not use Alpine. Sometimes it will work, sometimes it will not work. If it is not working, you need to understand the error and unknown distribution option, something like this. So just now, can you give me Python 3.9 Alpine image? Let us just give our everything. So we are getting this error, right? Let's just give this error also. Let us ask ChatGPT. Maybe it will correct immediately. Just give me one Python Alpine sample Docker file to install Python application. It's just saying slash Alpine. Let us see that whether it will work. So some of the packages it is unable to install from our this one. Open tracing, I don't require actually. So I can remove this open tracing and external also I can remove. Still some error with. Distribution option. Let us give. So as I said, you need to really spend some time if you want to work with Alpine. So let me try as the last option here. Seems working this time. As I said, bare minimum OS always comes with nothing installed. So you should take care of that procedure as well. Now Docker images our payment. You can see 327 MB, 1.03 GB to 327 MB. Now, generally, T2.micro instances will be enough if you reduce the size. Okay, earlier it was 1.03, now it is 327. So make sure your Docker compose up -d also should work. Okay, let me just recreate it. Just check. Nothing in. So let me go for something part checkout. Payment is working, right? So we implemented many best practices. So we implemented official images, we implemented custom Docker files, that's fine. We kept the containers very small. You can just use just like the git ignore, you can just use Docker ignore to unnecessary copy the files into your Docker images. Okay, this is okay, fine. And now the multi-stage. So this is the main concept. So reducing the image size and multi-stage builds is the main concept. So let's take 5 minutes break and then we'll discuss multi-stage builds. So we'll come back at 8:33. Yes. So, and then now multi-stage builds. So multi-stage builds is, so as I explained yesterday, especially in Java environments. So we need JDK generally while developing the application, okay, to install the packages to compile. But to run the application, we don't need compiler. So that's why we go with JRE. Let us take our shipping. So this shipping, so let us see what will happen if I do it directly without multi-stage builds. Let me comment the whole thing. Let me comment the whole thing. This one also. Now I don't use multi-stage builds. Now let me use directly. So Maven as build and work directory of shipping. This is done and Maven package is done. We just give the environment. And then let us run command directly, but it is inside this. Okay, so this is without multi-stage build, referring the Maven and work directory and doing everything. Now let us see the size. Now Docker build, Docker images, let us see the size now. It is around 568 MB. Now Docker build -t join DevOps slash shipping v1 Docker. Docker images. Now you can see 631 MB. So almost 60 MB is increased. That is because of extra component compiler through Maven. Okay. So in these cases, especially in Java kind of environments, so I need the output of shipping.jar from here. I want to give it as input to this actual image, this one. So let me comment this. Comment here. So this is as build. This is going to be intermediate container. This will be deleted automatically. But after copying this output from this one, this Docker file, so this output will be copied here. And once this is done, so this one will be deleted so that we can reduce the memory by removing this Maven. So in this image, we don't have any Maven, right? That is the advantage. Let me just use it as Maven, right? Yeah, we already commented this. Okay. So this is the builder. So builder image is going to be deleted automatically, and then this one is going to be persisted. So even I can reduce the memory here. So I don't want to use JDK as I said. So these guys, they just use JDK. I even can reduce the image. We can use JRE Alpine version. Let me check open JDK. Inside open JDK. So there will be 8 JRE Windows. I don't want Windows. I can say Alpine. Okay, you can see 8 JRE Alpine. Now I will use this image. I even reduce it more and pushing it to full. Now Docker build. Now let us see the image size, Docker images. It is 126 MB. You can see how much it is reduced. Let us again Docker compose up -d. So shipping is recreated. Let us test this is working or not. Start, check out. Yeah, it is working. Start, check out. Shipping. That is working. So multi-stage build is a way of reducing the image size through build. So we'll keep like 2 Docker files. We will use one Docker file as builder and we will copy the output into the second Docker file. So automatically the first image will be removed so that we can reduce the size. So that is the explanation. If someone is asking about multi-stage builds, we can use this especially in the Java environments. Okay. Build tools or dependencies during development, but not in production, right? So we don't, Maven is a build tool. We don't need it in production. So multi-stage builds is used to create the final image. So this is how we can implement multi-stage builds and update dependencies. This is fine. That's a developer job. Limit privileges. So limit privileges. Now let us take any container. For example, our cart, Docker exec -it cart bash or sh. Now you can see it is the root access. So if you give root access, as I explained in the last session, if you give root access to the users, uh, they can get the access to the underlying host. They can access the other containers. They can do whatever things they want. So it is not advisable to give root access for that purpose. So these are the best recommended approaches is using multi-stage builds and then limit privileges as part of security. So it is also one of the important question. How can you improve the security of Docker images and containers? So the security, how can you reducing the image size is not part of security. So limiting privileges is part of the security. And then isolate containers. Keeping your own network is also as part of security. Okay, so now we need to create a user. So we should not use root image. So we'll discuss this and then we'll close the today's session. So now, so what I have to do here in our cart, so this is the Alpine OS. I need to create the user. I should not use the root user. I should use the another user. So like adding user and group in Alpine. So you will get the commands generally from official Alpine documentation. Add user is the command. But this is going to be system user, not a human user. So generally for system user, we can say -yes. Okay. System user is nothing but they don't have, they are not humans. So they represent the application. So now here, what I can do inside cart, run, add group. First I'm creating group, cart, okay, and then add user -yes, generally system user, that is system user, add user, username and group name, right? Add user -s is the option, system user, group name is going to be cart, username is going to be cart. So now what will happen? We are creating one group cart and we are creating one user cart and then adding the cart user to the cart group. Now this one, I can make it generally from here user cart. So that I can make sure every instruction later to this is going to be run with cart user. But I cannot do immediately here because this one, opt server, it is creating the directory. If it is not exist, then this needs sudo access. So I will let create the directory with sudo access. And now I need to give the permissions, change ownership, cart :cart. So to this, to these two commands, I require root access. So I'm not keeping it. Now here I will keep it. Okay. So I created the directory. I changed the ownership. Now I'm back to the user part. So at least actually this should be at least at the last instruction. So that whenever somebody log into your container, they will not get the root access. Right. So now let me push out of this. Hit full cd cart docker build -t join DevOps /cart :v1 dot. So now docker compose up -d. Now docker exec -it cart --sh. Now you can see it is not root access. So he cannot do anything. He cannot get the access to the host. He cannot get access to the other containers. Nothing. So this is one of the mandatory thing you should implement. More than this is the first thing you should implement generally as part of images and containers. So isolate containers, we already did this through the network, and then monitoring and logging. So logging, generally whatever the logs we are getting here, so those logs are temporary, right? So I can only get the logs like docker logs cart. I can only get the logs few lines, but to persist the log, generally you have to use Elastic cluster, Elasticsearch, and then Kibana, that we will use it with Kubernetes. And then, so they are saying container management. Orchestration tools like the Docker Compose. We already use Docker Compose, but that is not the best. So that is why we are going for the best solution, that is Kubernetes. So next topic is on Kubernetes. And then data. Volume, backup the data is nothing but use volumes. Okay, and we will use this in Kubernetes also, that is storage, and use environment variables. We are already using it. Implement CI/CD pipelines, we are going to do that. And scanning also, we are going to do that. And Docker Compose, this topic. So almost we are using everything. Few we are at to implement, but these are the best practices. At least we use half of them. Okay, more than half already. So few things will come up in Kubernetes section. So I can say there is only one simple concept, that is Docker layering. We will discuss that tomorrow. We will wrap up the Docker. We will discuss the disadvantages of Docker, and then we will implement the next best solution, that is Kubernetes. Any questions? Yes, Raghu.
Hey Siva, good morning.
Hi, good morning.
Can we discuss about that scanning, Docker scan or image
Yeah,
scan?
when we push that to the AWS, we have the scanning feature available in AWS. We will use there.
Yeah, sure. Thanks.
Anything else? So if no questions, we can end the session. Have a nice day. See you in tomorrow's session. Bye-bye.